a reminder that really all of this stuff is really just dynamics and kinematics, but now instead of things going sideways, it's going up and down, right? So it's really kind of just a review with a 90-degree twist kind of thing, right? So a quick reminder of some formulas. We got Fw equals mg. We got g is our constant, 9.8 meters per second squared. That should be squared, not a 2. If I can do that here. I can. I see a problem here. Does anyone else see a problem?
Yeah.
No. I see a problem on that very first formula right there, and I thought I fixed it. Is this a formula?
No.
What should it be?
Delta D over delta D.
Exactly. That V should be a D, right? V bar is delta D over delta T. Delta V is Vf minus Vi. V bar is Vi plus Vf over 2, and A equals delta V over delta T. And I should sort of give you a bit of forewarning. When you get to grade 11, we take those formulas and we kind of combine them a bit, and we make them a little bit more useful. Or grade 12. Thank you. What's that? No, I'm not warning you. I'm just giving you some. Maybe that was a poor choice of words. Yeah, heads up. Yeah, this is a good warning, right? Yeah. All right, so here we go. Example number 1. Demon Drop is a ride at an amusement park. You watch it, time its free fall time at 1.5 seconds. Now, I'm likely the only person in the room that does this sort of stuff at amusement parks, but I'm a nerd, so whatever. How fast is it going when it reaches the bottom, and how high is the ride? So let's just go through this here. What do we know? Now, because it's vertical, you always know the acceleration is minus 9.8. It will very rarely come out and say that in the question. Right? So that's just something you got to know. A equals minus 9.8. And the free fall time is 1.5 seconds. Okay, what are we solving for? How fast is it going when it reaches the bottom? Now, the other thing that isn't told either is that it's free fall, right? It's dropped, and so that means that the VI is 0. Cole, stay with me here. You look like you're just looking around for someone to talk to. How about you look around, let's look for someone to listen to. I'll be that person. That's the VI is 0. And we want to know how fast it's going when it reaches the bottom, so we are solving for the VF, the final velocity. Now, is doing that stuff on the left, is that mandatory? Do you have to do that? For some people it helps, yeah. There's no shame in doing that. When I sort of get a tough question, I will do something like that. But remember, a lot of these questions I've done over and over again, right? So I have to remember as well that I need to model that for you. So if I do tend to stop doing it, then let me know. How fast is it going when it reaches the bottom? So we're looking for VF. So what can we get out of A, T, VI, VF? Well, but out of A and T, I can get delta V, right? I've got A, I've got T, I can get the delta V, and from that, I can get the final. Right? So yeah, that's what we're going to do. So step 1, A equals delta V over delta T. Now, I still know that there's some people that are kind of fighting me on this, you know, showing formulas, showing work, lining up equals. Trust me, the problems are going to get bigger and bigger. The sooner you get into the habit, the better.
Like roller coasters, do they ever like pull you back to reality?
Oh yeah, they could. I would think. Maybe not. I mean, they're almost always going to be at some angle, right? And it's probably just free fall, so I'm going to say no. Yeah. Well, I'm just saying that there's never, like, they pull you up, right? The motor pulls you up, the chain pulls you up, and then after that, it's just gravity lets you go, right? Yeah. I would say no then. Okay, so we got delta V. Our time is, say again? Oh, why is the acceleration negative? Because it is down, right? Now, is it always mandatory that you put in the negative in there? It comes from experience. and doing questions. Like, I know that I'm going to get a thing at the end, a final velocity at the end, and I know that that final velocity is going to be down. It should be shown as negative. So that's why I just naturally put the negative in there. So 99% of the time, yes. There is a formula I just did with my grade 12 this morning. It's V equals the square root of RG. I won't get into it, what it means, but radius times gravity. If you put negative 9.8 in there, you're going to have to take the square root of a negative, and it's going to crash on you, right? So there are times when you can't do that. But for the most part, yeah. Okay, so delta V is minus 9.8 times 1.5. And what do you get there? 14.7. Minus 14%. Zane, you had your hand up there for a while, and I missed you there. Okay. So I get, now if that's the change in the velocity, theoretically you should really, by all rights, you should really go delta V is VF minus VI. I'm sorry, am I in the way there, Dawson? Does that help a little bit? Okay. So now this is minus 14.7. We're solving for VF, but the VI is 0. So in other words, it's just that, right? Do you have to show that step? I would prefer it. At the very least, you should at least do this, right? And just tell me that you understand that delta V and VF are two different things. When is the delta V equal to the VF? Only when the VI is 0. Only when it falls from rest. Yeah. Yeah. Yeah.
But I'm accelerating like
Okay, so now when I'm, oh, Cole's got a question. No, not like that. So now we're looking at how high is the ride. And because it's a D value, right, we're going to need the one that has V bar in it, right? We're solving for D.
So we need V bar.
So we need V bar. Okay, Brandon, enough. Stick with this conversation, please. So we're going to find the average. This is going to be 0. This is going to be minus 14.7 divided by 2, or minus 7.35, right?
Yeah.
And now you can do that other one. Now, should this be negative 2?
No.
Like, my D value ends up being a negative, right? 7.35 times.
But the negative means down.
Exactly. Yep, the 7.35 times 0.5. Yep. 11.03, we'll say. And you're right, Leo. The negative just means that it's down. That's all it means. Yep. It's actually, the D stands for displacement, right? So it's dropping 11 meters.
So that might just be where it evens out.
Yeah. Well, I'm thinking about, this is one of those rides where like it's like the big pole and they crank you up and then they just let you go and drop you. It's not like a roller coaster kind of deal, right? It's just a free fall kind of
Oh,
thing.
that makes sense.
Yeah.
Similar kind of question here. Tennis ball is thrown upward with an initial velocity of plus 22.5. It's caught at the same distance off the ground from which it was thrown. So in other words, the displacement is 0 because like it's thrown from like, shoulder height, tossed up, Leo, caught at the same point. So the displacement is 0. How high does the ball rise and how long does the ball remain in the air? So all it is straight up and then coming down. Is the time up equal to the time down? Does it take just as long to go up as it goes down?
Yeah.
Is the distance up the same as the distance down?
Yeah.
Well, that's for sure. Right? Okay, so how high does the ball rise? So we're solving for D. Now, there's a couple things here that you already know. We're solving for the D. Do we have VI? We do. The VI is plus 22.5. Do we have the VF? 0?
0, yeah.
Where is it 0, Dawson? Right, like right here? And at the top. Oh, no, okay. It's not zero, it's zero after you catch it, but it's certainly not zero as you're catching it, right? When you throw something up, it's going to, right? It is 22.5, but that's negative, right? Dawson is right, and I heard AJ say it too. The VF is zero. Whenever you have one of these up and down kind of deals, try to treat it as sort of like two halves, two intervals, I guess you could say. Right? So here the VI is 22.5, and on the way up it slows down, and that final velocity is zero. And not only that, but our acceleration is, again, minus 9.8. And we want to know how high. The one that has how high in it has the V bar in it. So let's go V bar equals VI plus VF over 2. Initial is 22.5, VF is 0, divided by 2, 11.25 meters per second is your average. Stay with us, Junior. And now that you got that, V bar equals D over T. 11.25, solving for D. Oh. We don't have the time yet, do we? If I'm going to go V bar equals D over T, I got to have the time. Now, I got two choices here. I could just do this like some of you do, or I could not do that. Actually, I got three choices. I could do that like some of you do, or I could just do this and then put my next step somewhere else and make me figure out the order. Or you could get out your eraser. How am I going to get the time? The formula has time in it. Yep. A equals delta V over delta T. Kind of like a puzzle. Minus 9.8. We're going to solve. Now, what is my delta V? I guess I really don't have it, do I? It's 22.5?
Yeah.
How do you know that?
Because you have to define.
Yeah, it starts at 22.5 and it ends at 0. So, in fact, it's not plus 22.5. It's actually, Leo's right, minus 22.5, right? It ends up at 0. It starts at 22.5, 0 minus 22.5. Because the time has to be a positive value, right? Do the old switcheroo there. Minus 22.5 over minus 9.8. Yep. Right? The T and the 9.8 just switch spots. 2.3 seconds is the time up. That's actually the answer to B, isn't it? Right? That's actually the answer to B. We're going to have to do it out of order here a little bit here. So now you're going to go V bar equals D over T. This turns into a multiply. Well, there's some people that are still struggling with this, unfortunately. You guys got to be able to do that. If you need help with it, I'll find thousands of sheets. Well, you just got to learn it. 25.9 meters.
Why did they just switch water?
Here? Multiply both sides by T, and then divide both sides by minus 9.8. Why do you do what? Because I want to get TO by itself. And then what's going to be on the right hand side? Not T, it's going to be 1 over T. It's all the T's on the bottom.
Oh, right, okay, yeah, I got you.
We had a sheet on this.
Okay, now this one is actually true. Canada's Wonderland. Anybody been to Canada's Wonderland in North Toronto? Oh, lots of people.
What?
You ever been to Canada's Wonderland, Junior? It's a big amusement park. It's like Canada's version of Disneyland, without all the goofies. Just oddly enough, when I was at Canada's Wonderland, oh so many years ago, I stood in front of this ride and actually timed its fall because I was interested in how tall it was. Yeah, I did. And then I went online back in the hotel and found out I was close.
That's what they asked.
No, I just stood there and
That's
went.
what I asked.
And my wife said, "What are you doing?" Nothing.
This time it's rides.
I'm just talking this ride, you know.
They had this other ride.
Terrifying.
Okay. So this one here is a drop ride. It's 70.1 meters tall. How fast are you going when you reach the bottom ride if it takes you 3.8 seconds to complete it? This time I know the displacement. I always know the acceleration. And I know the time. What do I have to find? How fast are you going when you reach the bottom? I'm solving for VF. Do I know the VI? Yeah, it's a 0. So I know a lot of things.
That's 3.8.
Yeah.
3/4.
Okay, so how fast are we going when we get to the bottom? Which one has VF in it? Well, I'd have to know delta V, I guess, right?
Yeah.
I can get that from these two, right? A equals delta P over delta T. Stay with us here, McCready.
Oh, I'm with you. All the way.
Minus 9.8 is our acceleration. We're going to solve for delta V. The time is 3.8. Am I ever going to need that D value?
Yeah. Yeah.
No. That doesn't seem right. 9.8 times 3.8. That's better. 37.24.
What would you get?
300 and something.
Oh, nice.
37.24 meters per second. And because the VI is 0, therefore the final velocity is... Oh, no, that should be negative too, shouldn't it? Probably. Actually, I think what happened was the original question was... Have you guys done systems of equations yet in grade 11 pre-calc? Where you got like, you know, like x plus y equals 4 and x minus y equals 8. And you got to get rid of one by adding or subtracting. Remember those? Okay, well, that's what this question was like, where you've got more than one unknown. And it always blew the grade 11s away, so I changed the question. And I think I just forgot to get rid of the 70.1. But it's a good lesson to learn that sometimes there might be a number that you don't need, right? Yeah. It's really displacement, which is why it can be negative, sorry. Yep. All right. So this time we got a ball that's dropped from a tower 70.1 meters high. How far will it have fallen after 1 second, 2 seconds, and during the 4th second? So here's the tower. Okay. Here t is equal to 0. At some point here, Brandon, t is equal to 1. At some point here, t is equal to 2, and it looks like I didn't draw it tall enough. Right? Because it's speeding up. And then, well, who knows where 4 is, right?
Somewhere down.
Somewhere. Okay. How far will it have fallen after 1 second? So I'm really looking for that one there. But can we call that one D1? The displacement during the 1st second. And the 1st second is between 0 and 1, right? Okay. So, What do I know? I know the time is 1.
Time.
I know acceleration. With acceleration and time, I can go A equals delta t over delta t. So minus 9.8 is my delta v, and it's just 1, so that's easy. So it's minus 9.8, which means then that my VF is minus 9.8. It's going 9.8 meters per second down after 1 second. How far will it have fallen? 9.8 meters?
Yeah.
It's going 9.8 meters per second. Will it have fallen 9.8 meters?
Yes.
No,
No, because it's gonna speed up.
because it didn't start at 9.8, it started at 0. Part of that time it was going 1 meter per second, and then 2, and then 3, and then 4. You got to find the average, don't you?
No.
Now, it's not particularly hard. In fact, it takes longer to write it out than... It's really just... See, and the reason why I do it this way is to give you a greater appreciation for the grade 12 formulas. You look back at this and go, oh. So that's going to be 0. Well, you might say other words, but... Yeah, so we'll just say them to yourself. Minus 4.9 is the average, right? And now d bar equals d over t. Minus 4.9. One second. Oh, this is easy. Whoops. It's fallen 4.9 meters in the first second. How far will it have fallen after? Yeah, that's D1. Right. Why 9.8? Guessing? So this is all part A, right? So how are we going to do part B? Just multiply everything by 2? Is it not just going to be exactly the same 3 steps, but instead of 1 second, it's going to be? Excuse me. It's going to be 2 seconds, is it not? Yeah. How far will it have fallen after 2 seconds? Do this and plug in a 2 for the time. Hey, if you get upset, remember that I do this every semester.
You do it on purpose. You want to do that for a You literally do physics for fun.
Yeah, you literally told us you do physics for fun.
I did say that, didn't I?
Got him.
You got me. Well, look at it this way. How much fun I'm having doing it. You too can have this fun.
Right.
Right? Hey? Gotcha.
Funny jokes.
That's not how it works.
You can have it, Dawson.
You multiply.
6 more years. Multiply by 2, right?
Yeah.
Is the initial going to be different? It's after 2 seconds. So that means that it started, we're really talking about that right there, right? So it's the same thing here. Ah, right, you are, Brett. I think Brandon's right. He just said 9.8, right? What's the average here going to be? Boy.
Some kids.
I'm actually sometimes good at this.
There's one little twist. That's averaging 9.8 meters per second for 2 seconds.
So it's gonna be nice.
So guess what? Here, you got minus 9.8 here. You're solving for D2, I guess. And the time is 2. So we just divided by 2, and now we're going to multiply by 2.
Yeah.
The good news is you don't need a calculator, hopefully. it will have fallen 19.6, a total of that, after 2 seconds. Let me just clean that up.
Why? Now we got faster.
Well, I just want to talk about this for a second here. Hang on. Okay, so after 1 second, it fell. This distance right here is 4.9, and this total distance over here is 19.6. Which portion of that trip, like between 1 and 2, or between 0 and 1, or between 1 and 2, did it travel farther?
Yes. Neither of them the same distance.
Are they? This is only 4.9. From there to there is 19.6. So how much is it from 1 to 2?
Just subtract.
Yeah, it's 19.6 minus 4.9. What's that? Yeah,
14.7.
14.7. It moved 14.7 meters between 1 and 2 seconds, which we would call the second. Right? But this distance here, this 14.7, would be the second. Right? The first second is between 0 and 1. The second is between 1 and 2, and that's 14.7. So how would we do part C during the 4th second? You'd have to find what? The 4th second, this is the first one. This is the second one. Between 2 and 3 is the third. So during the 4th would be between, it'd be right here. This would be the 4th second. So
4 seconds.
you'd have to find out where it is, how far it's gone after 3, and how far it's gone after 4, and then do what? Subtract. Yeah, it is. Well, it would be exactly the same as this, except that it wouldn't be 1 and 2. It would be 3 and 4. So how much would all this be worth? Maybe 6. 1, 2, 3, 4, 5, 6. And I guess a subtraction. No, you wouldn't have to do all this, right? You just have to do all this all over again with 3 and 4. Oh, how much would this whole thing all be worth? I would never give you this question. You're doing the same thing over and over again. I'm not going to get you to do that.
Okay, fair enough.
That's good.
Right? In fact, I'm not even going to get you to do this. Yeah. What I probably should do is change this to during the second. And then that answer would be what? Let's do that. Let's do that right now. Change this. Scratch that out. We just did it, yeah. Scratch that out so it says second, and then you just put 19.6 minus 4.9 is 14.7. That's way better. Right?
14.7 meters.
Why does it go so much farther in the second? Yeah, because it's going faster. It's going way faster during the second. Like, the first second is between 0 and 1.
Like right on the board.
The second one between 2 and 3. Did I give you the second sheet or just one today? Just one? On example number 2, I didn't do the second part where it says how long does the ball remain in the air. So, Brandon, I'm still talking up here. You guys can talk rugby later. So the total time, I'm going to put TT would be 2.3 plus 2.3. The total time would be 4.6, right? I forgot to do that step. Right? How long does the ball remain in the air? This is just time up.